All right, hey everybody. This is day number 11 on distributions using calculus. Specifically, we're going to look at this thing right here. This is called a probability density function. And what it is, in reality, is a piecewise function that represents an area under a curve, which can help us to visualize probability in the form of area. So what you'll notice here is that we've got two stems of this probability density function. We've got this first part, which gives us an interval in which there's a function. And we've got some unknown k here, which we're going to find in a minute. So the outputs of the probability density function on that interval are based on k sine x. And in this case, otherwise, we get 0. So the entirety of the area in this case will be underneath the curve from 0 to pi over 2. And with probability density functions, that function itself, right, the area from 0 to pi over 2 of k sine of x should equal 1. Okay, so all probabilities add up to 1, therefore that right there is kind of our first identifiable workable formula. Okay, and that's going to help us actually in part A to find the value for k. So let's jump right into it, and then we'll start talking expected value and median after that. All right, so what I'm going to do is I'm going to integrate said thing, and I'm going to find a value for k such that this would be true. So I integrate sine x, getting its antiderivative to be negative cosine of x. And of course, that'll be times k. And I'm going to evaluate from 0 to pi over 2. Love pi over 2 with cosine. That'll make things simple. So I'll have k times negative cosine of pi over 2, which is 0, minus a negative cosine of 0, which is 1. So I get k times 0 plus 1 must equal 1, therefore k must equal 1. So now what we know then is that this is just sine x. Okay, so sine x, right, we know the graph of sine x, and we know what it looks like from 0 to pi over 2. So I'm going to help you visualize what we're looking at here. We're going to go from 0 to pi over 2, and sine x obviously will have a max value on this interval at pi over 2. It's not that well sketched, but we'll deal with it. So this probability density function, the entirety of its area is under the curve from 0 to pi over 2. Otherwise, it's 0 everywhere, right? So you can imagine that the function itself takes on an output of 0 everywhere else. So the area under this part of the curve should equal 1. Okay, so the expected value, let's move on to part B. All right, part B is the expected value. And what you might remember from before is that expected value is from I equals 1 to n of all of the x values times all of the probabilities of each of those x values, right? So we took out of a list and we took the x's times the probabilities. In this case, it's very similar, but what we're going to do is we're going to integrate for part B, and you can see it up here. Okay, we're going to integrate from A to B of x times f of x, and in this case, f of x is 1 sine x dx, where A and B, sorry, let's change this. Oh, wow, small eraser. Wow. I'm going to leave a little bit of something there for those of you who don't like that. Yeah, let's make it look like that. Okay, cool. So I'm going to go from 0 to pi over 2 of x sine x. Okay, that's going to find me the expected value. Okay, and remember, expected value is like the mean, the average value. We'll look at what that means graphically in just a minute. Now, if I integrate this thing, this is going to require me to use integration by parts. So u will equal, looks like in this case, x dv is going to be sine x dx. So du will be dx, and v will be negative cosine of x. All right, so I set my integral up. This integral, 0 to pi over 2 of x sine of x will equal uv, which would be negative x cosine x, minus the integral from 0 to pi over 2 of v du. Now the negative, this negative with cosine of x is going to make this negative positive here. So it'd be like minus a negative cosine of x. So I'll just negate those and finish this up as follows. Of course, this would be evaluated 0 to pi over 2 as well, but I'm going to combine those in just a minute. All right, so I get negative x cosine of x plus sine of x evaluated from 0 to pi over 2. And this is going to give me the expected value, right? The expected outcome right here. Okay, so let's evaluate. That'll equal, if I plug a pi over 2 in, that'd be negative pi over 2 cosine of pi over 2 plus sine of pi over 2. Okay, minus, and don't assume because you're plugging in 0 that you automatically get 0, even though in this case you do. It'd be negative 0 cosine of 0 plus sine of 0. Okay, so just a reminder, cosine of 0 is 1, but 0 times 1 is 0, and sine of 0 is 0 as well. Don't assume though, always go through the motions just in case. All right, so the expected value of x will be negative pi over 2 times cosine of pi over 2. Cosine of pi over 2 is 0. Therefore, sine of pi over 2 is 1. The expected value of x is 1. All right, so what does that mean graphically? Up here, the expected value of x. Expected value of x. Okay, pi over 2 is like 1.5 something. The expected value of x is right here. Right, that is the mean. That is the average of the x's, right? And now it doesn't really necessarily, you might think, well, it should be pi over 4. Well, it's not based on all these heights, right? So each of these takes on a different priority based on its probability, its output. Each of these outputs have different weights. So expected value of x here is 1. Now let's talk about the median, okay? Part C in the median. What is the meaning of the median? Well, the median is that midway point, right? It's where half of the data can be cut directly in half. So I want to know where the area of the curve, under the curve, comes out to be what x value. That was weird. It looked like a Dr. Seuss question mark. Where that probability, that area ends up being 1/2. This value right here, this is going to be m, the median. Okay, so I'm going to integrate. This is part C now. I'm going to integrate from 0 to m of the function f of x. And I want to find out where that equals 1/2. Okay, so logically, let's think about this. Is it going to be right smack in the middle? No, right? Because the curve isn't symmetric. Right? It's not symmetric about some point on the curve, on the x values from 0 to pi over 2. So I'm expecting it to be a little closer to pi over 2 than it is to 0. So let's figure this out, find out the math behind it. So I'm going to do antiderivative sine x, which we know is negative cosine x. I'm going to evaluate from 0 to m. I'm going to leave m unknown. I'm going to set it equal to 1/2, and let's see what happens. So that'd be negative cosine of m minus negative cosine of 0 equal to 1/2. Okay, cosine of 0 is 1, right? And cosine of m, I don't know what that is, but I'd get negative cosine of m minus a negative 1, which is plus 1, is equal to 1/2. So I'm going to subtract, giving me negative cosine of m equal negative 1/2. So cosine of m is equal to 1/2. And of course, on our unit circle, We know if cosine of m is 1/2, that means m is an angle, and it's going to be pi over 3. So our median here is pi over 3. So that means, let me see if I can make the tip of this a little bit more aggressive. Okay, that means at pi over 3, at pi over 3, this blue 1 might not be placed very well, but at pi over 3, we have accumulated half the area under the curve. Of course, this is human error. I don't know. That's probably not exactly where it should go, right? But conceptually, that should make sense at this point. All right, I'm going to move on to one more example, and then the third example will be yours for homework. Okay, here we got another random variable, x, with a probability density function given. Now our values are going from 0 to 2, right, on our x's. And our function is this thing. It says in part A to graph it. Let me make the tip of this pen a little finer in its thickness. Okay, I'm going to sketch this graph. And it looks like, based on the graph, I'm going to have x-intercepts at 2, at -1, and at 0. Now notice that my interval only goes from 0 to 2. So I'm going to go from 0 to 2. And I'll just put one here at -1 just so you can kind of see what the graph is looking like. Right, this right here, I see a negative x value. So this is telling me my cubic, right? I got x to the first, I got x to the first, I got x to the first. Is going to kind of open like this. And all I'm worried about is the area from 0 to 2, right? So this area right here from 0 to 2 is going to equal big fat 1. That's going to be a 1, right? Because that's my only interval on this function where I'm accumulating any area. Okay, so I'm kind of scratching this area over here. I don't really care about it. I'm going to work with this. Looks like I'm not required to find the coordinates of the maximum. By the way, if I found the maximum, right? Let's just say I found the max. That is also, right? That is also actually considered the mode or the modal value, right? So if you wanted to find the mode, you would take the derivative of f, set it equal to 0, okay? And provided the function is concave down, so provided that its second derivative is less than 0 and its first derivative equals 0, you've now found the mode. Could it be bimodal? Yes. So you want to be careful, but I'm not going to address the mode in this particular example. So here we go. Let's find the value of k. All right, so I know that the integral, I'm going to pull that k out, leave that x in like this, and go x plus 1, 2 minus x dx. And I'm going to go from 0 to 2, and I'm going to say that has to equal 1, right? The area under the curve, that red space, has got to equal 1. So now I got some algebra to do here. I'm going to keep the k on the outside. Let's hope I don't screw this up. Okay, I'm going to leave the x. I'm going to FOIL this. That would be negative x squared minus x plus 2x. So that'd be plus x plus 2 dx. I want that to equal 1. So I'm going to distribute the k and an x, which will give me the integral from 0 to 2 of negative kx cubed plus kx squared plus 2k. Now remember that k is a constant. All right, let's work our way back up here with an antiderivative. So that would be negative kx to the fourth over 4. This is why I always keep the constant on the outside. This is such garbage, but that's okay. Plus kx cubed over 3 plus k. Uh-oh, did I forget something? No, I didn't. Okay. Plus 2kx. Is that right? I think that's right. Nope, I made a mistake. When I distributed, I forgot to distribute an x here. So that should be an x. So this shouldn't be, what it is. It should be something different. Get rid of that 2. This will just be kx squared. Kx squared. All right, yeah, that's right. And I'm going to evaluate this from 0 to 2, set it equal to 1. Nice thing, when I plug in a 0, it's all gone, okay? So I will get negative k, and then when I plug in a 2, I get 16. Nope, I don't get 16. Yes, I do. I get 16 over 4. 16 over 4 is just 4, so that's negative 4k. Plus, that'll be, what is that? K times 8 over 3. And this will be plus 4k. So this is awesome. Check it out. My negative 4k and 4k cancel. And I get 8k over 3 equals 1. That means that k has to equal 3/8. So there you have it, you guys. We found the median. We found the expected value. And again, don't forget that the expected value, all that means is the mean. That's the average. And we've been able to find some constant k that's attached to the probability density function based on the property that the area under the curve, which could have multiple piecewise portions to the function, but would have to equal 1. Okay, that's it for day number 11. As always, let me know if you got questions. Hope you have a good day. Peace.